we have to create the hydrological model. So first of all, new, then we need to decide where we are going to put our folder. So that is one is this HEC HMS. Okay, no, we need to create new folder, right, and select exercise 3, Tamil Nadu, right, then create. Okay, then you have to create the basin. This load basin is there. Then you have to create terrain. This terrain. It's also th. Next, then you have to go back into find out the where we are say our DM data. So first of all, that is a arc. In the arc mail, that was the folder for Faridabad. That was the new folder. So there's okay. The recently folder. So recently it was it. Select. Alright. So then we have to come back here, then select th, then save, click save, then select, then redefine, then ATM, select 44, it was the 44, then save. Okay. So you will see this is the basin diagram. Now we need to add our project site over here. Alright, then go back to that was the we have something that this is the our project site too. Select, right, this is our project site. Okay, now we have to add in processing our processing sink. First of all, we need to click processing sinks, so it will find out the values where water will can accommodate. So then we need to processing drainage. We need to find out the flow path for the water, surface water. So as you can see, we have find out that processing drainage. As you can see, right, we have find out the drainage pattern. Now we need to do identify the streams. So okay, so we will just identify stream in 1 square kilometer area. So as you can see, we have find out the streams. All right, so as you, if you want to change the this of right, you just want to change these values, so you can change it. Okay, so you can see over here, this is the streams you have. Right, then you just need to click these breakpoints. Breakpoints should be at that location where your project site should become in the watershed. So as you can see, the our stream is going to this direction. Okay, flow is joining over here, so we have to, so your flow is going towards this direction, all right. So now you have to click over here. Okay, just one breakpoint, and second breakpoint you should click over here. All right, then you will see that your project site will fall in certain watershed. Now you have to come back on GIS, then delete elements, this types of basin, reach. Yes, we want to that. Then junction, then outlet. Okay. Yes. So as you can see over here, our our project site is falling in these. What is the subbasin 13, subbasin 14, and subbasin. As you can see, this is here is 13 years 14. It's just a number as per the water sets numbering. It's automatically select. So it's not a big issue to that numbering is the year is 14 and it is 13. So it's not any big problem. So alright, so this is our water set, our project site is falling so these three basins. So we will find out that values for these water set. Okay, and if you want to merge these water set, so you can just select and press shift and then click another one, then I press if you want whatever you how many ones you want to merge. So just can select these and select click on GIS, then come back to merge element. So when you click merge, so your water set will merge. Okay, all right, as you can see over here. Right now, now you have to parameterize your model. Okay, first of all you need to discretization. So this is the discretization. You can just structures change, then come back to you, and this is structure scriptization, as you can see. All right, this is 44 44 oh sorry, yes, 44, and then you have to just click, right click, and then fill, then repeat first value. So you will just see that your values comes right. This is the sale site 2000 by 2000. All right, so you can change it if you want, but there's no need to change because it's the default value, and it's okay. And close, then you need to come back. Canopy is the plantation height. All right, so simple canopy are using, or graded canopy, whatever you have, so just provide that simple canopy values. Right, so we use depth values, just fill. All right, okay, you are just thinking that 10 mm is the maximum storage and 5 mm is the minimum storage for each water set, and just fill it. Okay, dry periods or wet periods, both of them you are just selecting it. That's a simple method. Right, then you have to create a surface. Surface is also same as that. It's also it is responsible for the what is the surface containing grass or something. Right, so you need to provide that value. It is the same as the canopy, simple surface, but it's absolutely usually used to the subsurface data. So how much storage will be there. So I just think in F5 minimum just 50 is there, so I'm just thinking of that. This data will be provided by your client or your company, so it's not the issue to that. You can't find it because this data will be provided by your geotechnical members. Right, then you need to come on surface curve number. Right, if we are just considering if 80, so there is value will comes 12.7. I will tell you how to calculate it. Let's apply and close it. Then you will see that transformation values. Just need to calculate the lag time. Alright, so lag time you need to calculate. So first of all you need to come back and find reach. We have a length, copy length. So length we have to copy. Alright, so this and now need to provide the flow path slope. That is flow path slope. Then you need to select this basin slope. This is the slope is comes in percentage, right? Then this is the right, and this is the SCS equation for the time of concentration to calculate it. So this is the formula. Alright, as you can see, the length time is the power 0.8 multiply the CN number 1000 divided by CN number minus 9, right, to the power 0.7, right, then multiply G slope, multiply slope, average gradient slope, that is the basin slope, and that is and its power is 0. minus 0.5, right, so that value will calculate it. Then as you can see over here, this is the time in hours, and the 0.6 TC is the lag time, so this is the lag time. You can calculate it, right? Then I have to come back over here, right, then apply, then okay. Then you need to come. We don't have snowmelt data, we don't have any waste flow data, we don't have any snowmelt data, so we cannot use it. So for the Muskingum, we need to calculate it for the same thing, right? Okay. So because we can calculate it, so we have to come back again and reach will reach. This is the reach where we can calculate it. The Muskingum value. These are the Muskingum values. Okay. Okay, then comes and then value is coming. Okay, that is value is coming. Then you can see over here. This is our value is coming. Alright. So this is the same value we have just created from that. as you can see over here, this is the minimum average speed of the river bed. We are considering 0.5 meter per second, and the flood wave velocity will be 1.3 to 1.67 value in the range of the multiply average velocity of the river bed to the 1.67, so we will get in the value 0.835, right? As you can see, we can just consider maximum wave flow velocity will be achieved. So we are just taking this one, right? Then we need to consider Muskingum K. So that is the value of Muskingum K value, right? This is the Muskingum K value. And this is the Muskingum X value, that is 0.3. We are just considering because 0.052, so we are just considering the minimum mid value of each value. And then apply and OK. Then just save it. Then we need to compute. Sorry. Okay, we need to parameter. So we are just calculating total 50 years, right? 50 years. So we have just had the data in frequency in storm, so we will selecting the map representation method as a frequency storm, right? Then we need to come back over here and select subbasin yes. Then you can see over here, and then we need to select annual parts in non-emergency we are not considering, that is done. And yes, selecting storm duration for 1 day and intensity duration 5 minutes. Or intensity position is 50%. That 50% of runoff is distributing to the project side. We are just considering as a default value. All right. And these values will be defined by when you are just taking the data from the rain gauge station. So they are in that report. This is the intensity position will be defined. You cannot imagine or cannot calculate, right? So we have this data. So first of all, already we have to say this one. So we are just calculating this is the right. Then you need to go back. Right. Sorry, we need to then again you need to control specification. This is the control specification. You need to define here. You need to define just a day duration. So we are just changing that to 20 July 2024. Okay. Okay. 21 July 2024. We are just taking 5 minutes interval. Alright. As you can see. Alright. Then you need to come back simulation run manager. That is 25 here. That is 50 years. Sorry. Alright. Just taking error. So we have to select 6 minutes. Alright. As you can see that not even number, so that we have to take it number. This is also sorry. I think I made a mistake over here. Oh my god. 4. can see our result. That is the global summary. As you can see the result of that one, and this is the whole one, right? And let's see over here. You can see this is the hydrographs. That is the p values coming from that is over here. Alright, this is the flow values. This is the quantity of flow. That is now. That is the hydrograph for the subbasin. Alright, that is the direct runoff values. Sorry. If you are seeing that over here, your curve is not meeting at the 0. So you have to increase the duration. So you will increase the duration like 22. So you will see that hydrograph will comes. Will show as 0. So as you can see, this hydrogram is meeting at 0. Now your hydrogram is completely showing in full. So you can increase the duration, so you will see that your hydrogram becomes. Okay. That is the canopy overfill. Cumulative precipitation, you can see is the formula, right? That's it. Okay, thank you so much. As you can see, for the sink, the outflow you will see it is over there, and a combined inflows will comes. Here this one is nice, right? As you can see, this is the main result outflow that is passing over here, and this is the result that is. Okay, this is submersion one, that is flows coming from over that is the reach, that is the flows coming at the reach, that flows coming from the subbasin 13, right? Okay, thank you so much. I will explain if you need any help for further. Okay, then we can